Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's presentation on binomial distribution. Now let us recall the previous session. In the previous session, we have discussed about discrete and continuous probability distributions and solved some problems on both. Coming to today's presentation, today I would like to introduce the binomial distribution, and then we find the mean variance of the binomial distribution. So today I would like to introduce the binomial distribution, and also we find the mean and variance of binomial distribution. Now coming to the probability distributions, there are two types. The probability distributions are two types: discrete probability distributions and continuous probability distributions. And a discrete probability distribution is a probability distribution of a discrete random variable. And here a continuous probability distribution is a probability distribution of continuous random variable. And what is the discrete random variable? If x takes finite number of values, then it is called a discrete random variable. If x takes infinitely many values, for example, capital X equal to small x that belongs to a comma b in an interval a comma b, where a and b are real numbers. And we know that between any two real numbers there exists infinite number of real numbers. Therefore, here x takes infinite number of values. So, if capital X takes finite number of values, that comes under discrete random variable and discrete probability distribution. And if capital X takes infinitely many values, then that comes under continuous probability distribution. And here in discrete probability distributions, we have the binomial distribution and the Poisson distribution. These two are the discrete probability distributions. Binomial and Poisson distributions are the discrete probability distributions, whereas normal, t distribution, chi-square distribution, f distribution, all these comes under continuous probability distribution. So normal distribution or standard normal distribution or z distribution and t distribution, chi-square distribution, f distribution, all these are continuous probability distributions. So first we introduce the binomial distribution, and in the next coming sessions we will deal with the Poisson distribution also. Now coming to binomial distribution, this binomial distribution was discovered by James Bernoulli in the year 1700, and which is a discrete probability distribution. So binomial distribution is a discrete probability distribution. Let us consider an experiment in which there are only two outcomes, namely success and failure. So let us consider some experiment in which there are only two outcomes, either success or failure. So the only two outcomes. And there are some examples like tossing of a coin. When we toss a coin, there are only two possibilities, either getting head or tail. So in the case of this first experiment, either getting head or tail. Now, birth of a baby, either a boy or a girl. There are only two outcomes in general we consider. And auditing bill, verified with errors and without errors. With errors and without errors. And an advertisement on a television. So there are only two outcomes, either people watched or not watched. So all these experiments comes under experiments in which there are only two outcomes, either we name them as success or failure. So here tossing of a coin, if we consider getting head is a success, then tail is a failure. Similarly, birth of a baby. For example, if getting boy is a success, then girl failure. Similarly, if getting girl is a success, then boy will be failure. And auditing bill with errors, without errors. So without errors, success, with error, failure, let us suppose. Watched success, not watched failure. So in such experiments, we use the binomial distribution. So here, to introduce the binomial distribution, we should know the following things. Let an experiment be repeated n number of times. For example, tossing of a coin. This is the experiment. Let us perform this experiment 10 times. Tossing of a single coin. Let us repeat the same experiment 10 times. So let an experiment be repeated n number of times, which is called the number of trials. So n is called the number of trials. And let us suppose out of n trials, x times we got success. Out of n trials, x times we got success. That means, for example, a single coin is tossed 10 times and getting head is success. For example, let us consider getting head is success. So what is the probability of getting 4 times head? So out of 10 times, I want 4 times head. 4 times head. That means, what does it mean? X equal to 4 and n equal to 10. So if an experiment is repeated n number of times, that is called number of trials, and out of n trials, if x times we got success, then x is the number of successes. And hence, now here, for example, out of 10 times, if we get 4 times success, getting head is success, then what about failures? 10 minus 4, 6 times we got failure. So n minus x gives the number of failures. So if x times we got success out of n trials, then n minus x gives the number of failures. And let us denote the success, probability of success by small p and probability of failure by small q. And we know that p plus q equal to 1. The total probability is always unity. So for example, if we have p, we can find q using q equal to 1 minus p. Or else, if you have q, then that means q is given, we can calculate p using 1 minus q. So these are the basic things we should know. The number of trials n, number of successes x, number of failures n minus x, and probability of success small p, probability of failure small q. Now let us derive the binomial distribution formula. Just now we have discussed, if small p is the probability of one success, then how many successes are there out of n trials? Let us suppose x be the number of successes. Then the probability of x times success or x successes is given by p into p into p and so on. How many times? X times. So p power x. If p is the probability of one success, then the probability of x successes is given by p power x. Similarly, if q is the probability of one failure, then the probability of n minus x failures, because there are x successes out of n trials, n minus x gives the number of failures, is given by q into and so on q n minus x times. So which is q power n minus x. So the probability of getting x successes is p power x, and at the same time, for example, out of n trials, if we got x times success, it itself means that there are n minus x failures. These are successes and these are failures. So x successes means n minus x failures. So these two can happen simultaneously. P power x into q power n minus x. X successes p power x, n minus x failures q power n minus x. And this is possible in NCX ways. So getting x times success out of n times. For example, 6 times a coin is tossed, and let us suppose x equal to 2. Getting 2 times head, getting head is success. Now out of 6 times, getting 2 times head is possible in different ways, like first 2 heads, remaining all tails, or first and third heads and remaining are tails, first and fourth are heads, remaining are tails. Like this, there may be number of ways, and that is given by the 6C2. 6C2 gives a number of possibilities for this. So here, getting x times success is possible in NCX ways. Hence, the probability is given by probability of X successes is given by this NCX P power X Q power N minus X, the product of all these three values, NCX P power X Q power N minus X, and this is the formula in binomial distribution. So in binomial distribution, the probability of X successes is given by probability of capital X equal to small x is NCX P power X Q power N minus X, where N is the number of trials, X is the number of successes, N minus X number of failures, P the probability of success, Q the probability of failure. So this is the formula of binomial distribution, NCX P power X Q power N minus X, where all of you know how to find NCX, the combinations N factorial by X factorial into N minus X factorial. And this probability in binomial distribution is denoted by capital B X N P, this small b for binomial distribution probability, X the number of successes out of N trials with probability of success P. So this is NCX P power X Q power N minus X. So this is the derivation of the formula, and using how we get this formula, that is explained clearly here. And next, so we can define the binomial distribution as a discrete random variable capital X has a binomial distribution if it assumes all non-negative values. So R starts from 0, 1, 2 and so on, with the probability mass function given by just now we have derived. So NCR P power R Q power N minus R. For example, if it is X successes, NCX P power X Q power N minus X will write for R non-negative values. So 0, 1, 2, 3 and so on. Otherwise, it is 0 simply for negative values. So a random variable capital X which has the probability mass function given here is the binomial distribution, and the random variable X is called binomial random variable. And the binomial distribution function, so the cumulative probability distribution or probability distribution function is given by probability of X less than or equal to small x with sum of the probabilities with X is the maximum value. So R from 0 to N, NCR P power R Q power N minus R. So by adding the values R from 0 to X, you can calculate this binomial distribution function. And now examples of binomial distribution. The number of defective bolts in a box containing n bolts. For example, if there are n bolts, out of n, 6 bolts are defective, then we can find the probability of getting 3 defective bolts, 2 defective bolts and so on. The number of machines lying idle in a factory having n machines. So out of n machines, for example, x machines are idle. Or what is the probability of x machines are idle? That we can calculate. The number of postgraduate students in a group of n men. All these comes under this binomial distribution. And now the conditions for binomial distribution. The binomial distribution holds under the following conditions. First one is the trials are repeated under identical conditions. So trial means the repetition of an experiment, performing an experiment number of times repeatedly. So all the times the conditions must be identical. So the trials are repeated under identical conditions for a fixed number of times, for example n times. And second condition, there are only 2 possible outcomes. Just now we discussed either success or failure. And third condition is the probability of success remain constant in all trials. So in the first trial, if P is the probability of success, in the last trial also it should be the same. It should remain constant. Next, the trials are independent. That is, the probability of an event is not affected by the result of any other event. So the trials are independent. That means the probability of one event doesn't affect the other event. So these are the conditions for binomial distribution. Now coming to mean and variance of binomial distribution. The mean of binomial distribution is mu equal to NP. So we can use this as a formula in evaluating some problems. So mean of binomial distribution mu is NP and variance is sigma square equal to NPQ. And there is a recurrence relation for binomial distribution using which we can find the successive probabilities. So you see here the probability of r plus 1 successes is n minus r by r plus 1 into p by q into probability of r successes. So that means if r equal to 0, let us substitute, put r equal to 0 here. So probability of one success is n by 1 into p by q into probability of 0 successes. So to find probability of one success, we should know the probability of 0 successes. So if you have the probability of 0 successes, we can generate all the remaining values using this recurrence relation. Now for example, this is some 0.2 or something, then we can obtain p of 1. Now how can we find p of 2? Put r equal to 1 here. P of 2 is n minus 1 by 1 plus 1 2 p by q into p of 1. So let us substitute this answer here. So to find p of 2, we need p of 1. To find p of 1, we need p of 0, p of 0, and so on. So using this recurrence relation, we can generate all the probabilities if you have the initial probability p at x equal to 0. And now we can derive the mean and variance of a binomial distribution. Now the first one, mean of binomial distribution. So what is the general formula for binomial distribution? The probability of x successes is ncx p power x q power n minus x. And what is the formula to find the mean? Mu is the expectation of x. How can we find that? Since binomial distribution is a discrete random variable, discrete random probability distribution, so it starts from x equal to 0 to n. We use the sigma notation. Expectation of x is x into p of x. So let us substitute here. So 0 into p of x, x equal to 0, p of 0, plus 1 into p of 1, plus 2 into p of 2, and so on, n into p of n. And this is 0, this term vanishes, and 1 into p of 1. Put x equal to 1 here. So nc1 p power 1 q power n minus 1. Put as x equal to 2. Then 2 into nc2 p square q power n minus 2, and so on, n into ncn p power n q power n minus n. So just by substituting the formula for each individual value. So nc1, this is n p q power n minus 1 plus 2 into this nc2 is n factorial. So in denominator we have n minus 2 factorial. So we can split up to here, and then that n minus 1 factorial gets cancelled. 2 factorial is 2. N minus 2 factorial will be cancelled, and these 2 terms also cancel. So we remain with this, and so on. Here NCN is 1. So p power n q power 0 is 1. Now here let us take np common. Then q power n minus 1 plus n into n minus 1 into np common. So this n minus 1 remains. P also taken, p into q power n minus 2, and so on. Here n already taken out. So one more p we should take out. So p power n minus 1. And what is the term in the brackets? So the term in the brackets is simply p plus q or power n minus 1 by the binomial theorem. So using the binomial theorem here, you see the expansion. It starts from q n minus 1 p power 0 and ends with p power n minus 1 q power 0. In general, if we have n here, we'll write p plus q power n. But here n minus 1 is there, so p plus q power n minus 1. Therefore, mu equal to np into, and what is p plus q? P is the probability of success and Q is the probability of failure, and P plus Q denotes the total probability, which is equal to 1. So this term will be 1. Hence, the mean of binomial distribution is mu equal to NP. Similarly, let us calculate variance. So variance of binomial distribution. What is the formula for variance? Sigma square is expectation of x square minus expectation of x whole square. This is the formula. And what is the expectation of x? Just now we have calculated, so which is NP whole square. So expectation of x square minus n square p square. Now let us calculate expectation of x square. What is the formula to find expectation of x square? Expectation of x square is given by sigma x square into p of x. So the sigma x square into p of x, as expectation of x is sigma x into p of x, this is x square into p of x. So x from 0 to n. Now let us simplify, or let us rewrite this term x square as x into x minus 1, so which gives x square minus x, so plus x into p of x. Let us write x square as x into x minus 1 plus x, just for our simplification purpose, and easily we can derive the value of expectation of x square. That's why we are rewriting this x square term in the form of x into x minus 1 plus x. Now let us multiply sigma x equal to 0 to n x into x minus 1 into p of x plus sigma x equal to 0 to n x into p of x. And you see here x minus 1 is there. So if you substitute x equal to 0, we will get negative term. So which is not possible for that. So we can write it as from x equal to 1 to n. For x equal to 1, we will get 0. Even I can start from n equal to x equal to 2 also. Here I can write 2, because for x0 it is 0, 1 it is 0, so x equal to 2. And here also, what is this sigma x into p? Sigma x into p of x is the mean expectation of x. So expectation of x square is sigma x into x minus 1 into p of x plus this is again np. Now here x from 2 to n. So let us substitute one by one. 2 into 2 minus 1, 2 into 2 minus 1 into p of 2 plus 3 into 3 minus 1 into p of 3 plus so on, n into n minus 1 into p of n plus np. So which is, this becomes 2 into p of 2. What is the formula in binomial distribution? NCx p power x q power n minus x. So let us use that. NC2 p square q power n minus 2. Then 3 into 2, 6. So the 6 into NC3 p cube q power n minus 3 and so on. And here n into n minus 1 into p of n, NCn p power n q power n minus n plus np. So after simplifying this, we will get 2 into NC2. Again, n minus 2 factorial will be in the denominator. So n into n minus 1 by 2 factorial is 2, p square q power n minus 2 plus 6 into n minus 1 into n minus 2 by n minus 3 factorial will be in the denominator, that will be cancelled, and 3 factorial is 6, p cube plus q power n minus 3 plus so on. The last one, n into n minus 1 into NCn is 1, p power n plus np. So again from this term, let us take np common. So again here we have n into n minus 1 term here. So we can take n common. P square also we can take common, because in the previous step we have this n square p square term is there. So let us take np square common here, because this term you see q power n minus 2, this completely p square should come out to get that binomial, to use that binomial theorem. So let us take n into p square common. So we are calculating expectation of x square is, let us take n into n minus 1 into p square common. Then what remains? Only q power n minus 2. Then plus the other term 6 gets cancelled. So n minus 2 into plus n minus 2 into p into q power n minus 3 plus so on. The last term n into n minus 1 p square. So here p power n minus 2 remains, n minus 2. And again, this is the sum of q plus p power n minus 2, where p plus q equal to 1. So this value becomes p square into 1. And this is using binomial theorem. So here this is n square minus n into p square, which is n square p square minus np square. This is equation 2, let us suppose, and the previous one, this is equation 1. So substituting 2 in 1, we get that it gives sigma square value. So n square, expectation of x square. So n square p square minus np square minus n square p square. And here we have one more term np also. So plus np plus np plus np. So these two gets cancelled. So np minus np square, which is np common. So 1 minus p, and what is 1 minus p? Is q. So that implies sigma square is npq. Hence, the mean of binomial distribution mu is np and variance sigma square is npq. Now, in the today's session, we have introduced the binomial distribution and evaluated the mean and variance of binomial distribution. And in the next session, we solve some problems on binomial distribution. Thank you.